So let's get started as usual. So Dave, see if you can share your slides. I'll just do a quick intro and we'll get the things going. All right. So
good. Can you hear me well?
yes.
Okay, let me do it.
Welcome to another OCP TAP session, call number 88. And today we have Dave Cavalcanti, which is a principal engineer at Intel Corporation, focusing on the next generation wireless connectivity and distributed systems to enable autonomous, time-sensitive systems and their applications. Prior to Intel, Dave was a principal member of the research staff at Philips Research. He received his PhD in computer science and engineering in 2006 from University of Cincinnati. He served as the president of Avnu Alliance's and an industry group facilitating an ecosystem of interoperable, time-sensitive network devices and deterministic networking across Ethernet, Wi-Fi, and 5G. He also serves as the chair of the Wireless TSN working group in Avnu Alliances. He has over 15 years of experience in industry and open standard development, and he contributed to several IEEE 802 standards, specifically the 802.11 Wireless LAN standard that defines several generations of Wi-Fi connectivity. He has published over 50 peer-reviewed papers and serves as a guest editor for several IEEE publications. He is a IEEE senior member and serves as the chair of IEEE Technical Committee on Simulation. So today's talk is about TSN testing and certification programs run by the Avnu Alliances. However, since we know Dave's past experience and involvement with 802.11, and we would like actually to perhaps, if we have time, ask Dave more about like Wi-Fi and how is like a precise time in Wi-Fi and so on. So until we get to that point where we can answer questions, let's see also the presentation about Avnu. So with no further ado, Dave, the floor is yours.
All right. Thanks, Ahmad. I also have here Ginil from Avnu as well. He is a co-chair of the certification working group, and Ginil is going to help me, present and discuss, right, the work we do in Avnu. And thanks again for the opportunity to share this group. Let's go ahead and please ask any questions if you have, and I'll be happy to discuss also other things related to Wi-Fi. The presentation is going to be a broader presentation, but we can talk more about specific topics, depending on the interest here.
Wonderful.
Okay. So the focus here is going to be about the TSN testing and certification programs that Avnu is running. And we'll start with a brief introduction about Avnu and why we're doing this. I'm not sure if the audience is familiar with Avnu or not, but the idea or the vision that we share in Avnu Alliance, right, and all the members that join the Alliance, is to enable this idea of converged network where you can have traffic of different types and different criticality coexisting on the same network, right? You may have time critical, time sensitive traffic and other types of traffic all on the same infrastructure. And then the goal, and this actually happening across different markets, right? Not just industrial market, not just, professional audio video is another market, automotive is another market. There are use cases across different markets. And the idea is this, the same kind of network solution that we enable can serve all these different markets. And we are seeing recently even applications that are merging across these two markets, different markets. Like, for example, we can see audio video now in the industrial space as well, so just to give an example. So a lot I think there's a lot of benefits to converge this different traffic in the same network. So Avenue is working to enable the ecosystem, and fundamental technology is based on time-sensitive networking to guarantee time and latency and with high reliability. We'll go in a little bit of the details of the TSN capabilities. But in general, and I understand the focus of this group, right, around time synchronization, right? So I would like to start with that. So time is one of the core capabilities for TSN and one of the core things that we do in Avenue as well. You know, the goal is to have time distributed across the network, right? And having a ground leader distributing the time across the network and have all different devices synchronizing to that, applying the required offsets, and have that time available to applications, right, that need to use synchronized time, but also have it available to network devices to apply some of the traffic scheduling tools and the TSN tools that we'll discuss briefly, right? So time is a fundamental capability for this converged network and to enable this time-sensitive traffic with other types of traffic sharing the same network. Once you have a time infrastructure, then the next goal is to actually guarantee deterministic data delivery within this network infrastructure, right? With certain latency bounds with high reliability. And as I show here in the diagram, right, when we look at this infrastructure, we see a combination of different types of technology, right? It can be Ethernet, but it can also extend to wireless, and that's one of the areas that has grown more in recent years with new capabilities being available in both Wi-Fi and 5G systems. So it's a hybrid network, but we need time distributed across the network, and then we also need data delivered with determinism across the network. When you have that, you basically can have these multiple applications coexisting with the different traffic flows, each with different requirements, with certain deadlines, right, with certain reliability requirements, all flowing through this infrastructure, and sharing the infrastructure, right, with mixed criticality applications. So that's the vision, and that's what we try to achieve in the end, right? Now, what are the core capabilities that Avenue is looking at, right, to achieve this goal? Is the time-sensitive networking, right? So this is a set of standards. You may be familiar with that, but just briefly, a set of standards developed by the IEEE 802.1 TSN task group. And the idea is that these TSN tools, they basically can augment standard connectivities or enhanced connectivity solutions like standard silicon, like Ethernet, right? Started with Ethernet, but some of them are already extended to operate over Wi-Fi and 5G, more recently, right? So these are the TSN tools defined by the IEEE 802.1 group. And without going to all the details, there are many standards. I'll show in a bit what they are. But the core elements of TSN, right, are these three. Time synchronization, right, distribution of the precise time between different entities of the computing system. Now, the latency goal is met through techniques to schedule traffic, to reserve bandwidth. There are different ways of doing that. So traffic shaping is a second step. And this really is about preventing latency due to congestion on the network, right? How you ensure when the time critical packet comes at a certain point or a switch, or an access point, is going to be is going to be transmitted without latency or with minimal latency. And then everything needs to be orchestrated and configured, properly. Configuration of these tools is very important. There is an assumption that if you want to guarantee latency, right, to some of these flows, you need to know ahead of time what are the requirements of the flow. So there are tools to share that information across the network and the network configuration element. So these are some of the core features in TSN. Now, if you look at this picture, you'll see the core components can be grouped in different buckets, like 4 main buckets. Like there are, and they are all defined in different specifications. You know, there's time synchronization, as I mentioned, is a core feature and maybe of a lot of interest to this group. You know, the .1 AES, 802.1 AES is the time synchronization specification for TSN, and is actually a profile of the IEEE 1588, right? Used for TSN, and it's called the .1 AES. So we'll talk more about that later on. And then there are the different features to control latency, a number of different traffic shapers, credit-based scheduled traffic, of frame preemption. There are different specs there, and there is still new specs being developed, right? This is an ongoing effort in IEEE. And there are tools to improve reliability, like frame replication elimination, like redundancy, and there are a number of different TSN configuration tools and protocols to how you configure this resource across the network. As you see on top, there are different components of TSN, and different industries may need a different subset of them. So to facilitate, how the different vectors or markets use TSN, there are groups that focus in defining profiles, right? Which is a combination of those features. That is started with audio-video bridging. So one profile is getting a lot of attention these days is industrial automation, for example, is defined by the IEEE IC 6802. So basically picking up a set of features and defining these are minimal requirements for that for application in those markets. And there are others like automotive, aerospace is a new one, and there's a couple of other profiles in front haul service providers network. Next, wanted to give a brief overview of, given all these ideas of convergent network, the standards in IEEE, how we position the work from Avnu Alliance, right? Where does Avnu sit in this whole ecosystem, right? As you see in this picture, the vision again from Avnu members is one TSN, right? Ecosystem for both wired and wireless networks serving multiple markets, right? And you see here, building, the idea is to build on standard connectivity like Ethernet, Wi-Fi, and 5G. So these are defined by different groups and certified by different groups, right? Like Wi-Fi Alliance for Wi-Fi, or other groups for 5G and Ethernet, right? And then there are the TSN standards and their profiles. So where Avnu focus on are the certification and testing for those TSN capabilities, right? So it builds on, it does not define the TSN specifications, but it's focused on testing interoperability and conformance for those, right? And again, trying to serve different markets. Again, Avnu is an open industry forum, right? Members can join, any members can apply for membership and participate in Avnu Alliance as well. So now going to a little bit more specifics, right? Okay, what exactly does that mean, in terms of work that is carried out within Avnu Alliance, right? So this gives a little bit more details. So you have the 802.1 TSN standards and profiles. And what Avnu does is look at those standards, right? The ones that are mature and ready, or almost ready, and then defines test specifications, right, for those features, right? How to test certain features, let's say time synchronization, that's one of them, right? Are there any questions? I could hear some, maybe it's a background noise. But test specifications is a core capability, considering both wired and wireless. So there are already test specs for different TSN features for Ethernet within Avenue and wireless as well for both Wi-Fi and 5G. I'll talk more about that. Developing test tools and working with test lab partners to be ready to test devices, implementations based on those test specs, right? And run certification programs where Avenue will certify certain devices for certain types of capabilities, right? Ginio is going to talk more about that shortly. And at the end, we can get Avenue certified interoperable TSN capable devices. Another thing that we also do in Avenue, and for example, in the Pro AV space, we actually do have a application level profile protocol that is developed within Avenue as well for the distribution of audio video, right? To build on some of those features as well. So that is a high level summary of the scope of Avenue. And now I wanted to hand over to Ginio to talk a little bit more about the certification programs that we are working on in Avenue.
Yeah, thanks, Dave. So yeah, so we have several certification programs in Avenue, and the one that is currently in the pipe, just to be released, upcoming new, this is the so-called Avenue Component Certification. And this certification is already validating on the silicon level the different profiles. And this is very interesting because it also goes, it's actually profile agnostic. So that means if a manufacturer offers a chip that has an 802.1 AS timing implemented, for example, we're having profiles that then can test for Pro AV part, for the automation part, and also for the industrial TSN, etc. And this is the fundamental level, meaning when we test this already, then the next upper layer application protocol, for example, only need to test what is needed for the application, but it can ensure that what is implemented on the silicon is working. And besides the GPDP timing protocol, we also have started with the traffic shapers. So in the release 1 is the TSN, the QBV. We also have the little bit older, the credit-based shaper, the QAV, what is also very interesting because even for non-time sensitive applications, this credit shaper helps already a lot to smooth out the traffic on a network. Then we have the QBU and we have the CB. And in addition, also we have started to do already the testings for the TSN, for the wireless with Wi-Fi and 5G, and there we support the GPDP, the 802.1 AS, and the QBV. Then on top of that, we also having the so-called Avenue Network Product Certification. And there is, of course, the essential part on the network are the network switches. And here, this program, it started actually with the AVB. And now, of course, with industrial automation, this is also integrated into the certification. And the work is ongoing, of course. First, we need to write the test plans. When we have the test plans, then the certification program can be created and released. We need to onboard the test labs. We see this a little bit later. Then another program is the Avenue Automotive Certification, and here it's the profile 802.1 DG. And like Dave already said before, we have a little bit more on the application level than the Milan certification. This is a Pro AV specific application network protocol to transport real-time media like audio and video in a deterministic manner. Then when you can change to the next slide, Dave, please. And here we see a bit the activities and the resources. And like I said before, when we start on the left, first, of course, there needs to be the test specs created. And as a lot of them touches different applications, profiles, this is, I would say, very interesting in Avnu because different segments, different industries can come together and work out together. They are the test specifications that are needed. And very often, for example, at the beginning, we hear, okay, Pro AV needs something different than industrial automation and then automotive also. But at the end, it's, I would say, there is always a core base that is going across. And therefore, it's very useful to have these different industries together in one association really working on it, because it's very enlightening and it helps to do this in a much more efficient way. Then we're having the test labs, like also mentioned by Dave already. We having different test labs across Europe, America, also in Asia. And this allows then companies to certify and yeah, go there to do the testings. Then, of course, another interesting part is also that we are having plenary and Plugfest meetings. So that's usually it's a spring and the fall events. And yeah, also there, different industries comes together. We can plug the things and figure out what is working, what is not working, improving. Yeah, the rest on the upper right, it's a bit what we have seen before. We have the new certification programs with the components, the Wireless TSN and updated switch program. Then there are different test tool options. So one is the Avnu Express test tool. This is something developed within Avnu with the members and is available to everyone in Avnu. And the interesting part there is also it's not only a certification tool, it's also a tool that can be used for regression testing, for debugging. So it's also possible to write own Python scripts, especially for developer when he's developing on a stack. It's quite handy. And there are also third-party tools, of course, like from Ixia, Keysight, and then Spirent. And another pillar is, of course, also that we have industrial collaborations with other organizations like TIAC. That's collaboration with different industrial automation associations, of course, with IEEE IEC 60802, what is the Industrial Automation TSN, and then, of course, the IEEE 802.1. This is where the main work of the TSN is happening in the IEEE. Yep, and here we have, for example, how it looks like when we are meeting together for Plugfest. So some happened a bit during the Corona, and we are doing different polls and groups where stuff can be tested. And then also we having a so-called all play where the different industries comes together, and because at the end very often things are living on one infrastructure, even if at first each segment thinks or believes he's the only one, but it's a network. So and there it's also important that when you do something in one industry that you not block another one. Yeah, Dave, I think with the next slide, you will go a bit in detail with the 802.1 AS, I think.
Yeah, thanks, Gino. And just to add on the PlugFest, right? We have several members with their devices participating. We have test tools there. So the Avnu team that coordinates the event actually schedules times for vendors to run conformance tests with the tools, interop tests between vendors, right? And that's an opportunity for device vendors, to really check their implementations, find bugs, and so on. So this is a very important and well received, events and well attended from the Avnu side. Okay, so this is the general overview of Avnu. What we wanted to do next is to go in a little bit more detail as one example of a TSN feature and how we test it, and give an example of types of tests what we test, which is the time synchronization, right? And in this case, we are considering the .1AS protocol, right? That's the profile of 1588 defined in .1AS for TSN. Any questions up to this point on the general organization? Okay.
Just one question, general organization. Do you have outreach between, obviously you have some sort of, lack of a better term, synchronization with, maybe coherence with IEEE, but what about with 3GPP?
We've had, some of our members are in 3GPP as well, right? So through that, three members do go 3GPP, but specific from the Avnu level, we've had some engagement, not directly with 3GPP, but we had with the 5G ACIA, which is an organization focusing more on the industrial segment for 5G. So we had some, discussions and potential collaborations when it comes to testing for TSN over 5G. So that happened, and a couple of meetings. We don't have a formal agreement, but we've had, we've reached out to them, and something we continue to do. We also have done it to WBA, right? The Wireless Broadband Alliance is more on the Wi-Fi side, for example, right? So these are examples, that we have done, and that's something we continue to try to do to the best of our, to the resource we have, right? To reach out and promote, whenever we see that TSN is a core capability, right? That's going to be needed.
Thank you.
Okay. All right, so we'll go in just a bit more details on the .1AS as an example. I thought it would be interesting for you to understand what kind of tests we do, right, for time sync. Again, a high-level review of what is .1AS is, or GPTP, right? Idea is to distribute time across the network. Again, the single reference time is used. The motivation for this, right, to enable that to be used by applications or network devices as well with a working clock. And in this case, the latest spec is the .1AS 2020. And I think one of the points that Ahmed mentioned earlier, right, about Wi-Fi, actually, I'll say a few words here, because this in the .1AS spec, you actually include already both options for Ethernet and for 802.11. So there is already in the standard a way that you extend the .1AS to operate over Wi-Fi or .11. And that's actually done by using the the .11 features, which are timing measurement, or more recently, fine timing measurement. So those are the features that are used on the Wi-Fi side to enable the .1AS. And these are all documented in the 8.11 and the .1AS 2020. So this was collaboration done between .1 and .11 groups. And these features actually available since a couple of years ago. Actually, I believe timing measurement was back in 2012, but FTM was more recent in 2016. Now I did not put here the frame exchange for Wi-Fi. There are a few differences when you use FTM than when you go over Ethernet. But this is the frame exchange for .1AS over Ethernet. You probably may be familiar with that already. But you have the PDelay request, response, and follow up with that. You capture the timestamps. You want it to 2, 3, 3, 4, and calculate the path delay, and you can send in time sync and follow up message, and calculate the offset right to the leader clock. So this is just the protocol, and what we do in Avnu is to write a test spec for this, right? And what kind of features do we test? For example, the test case include testing when your device operates as a GPDP instance and as a GPDP instance with relay option, right? We test the signaling message, conformance to the signaling messages defined by the protocol. And we test conformance for the .1AS state machine, the best master algorithm, or the different types of send and receive message there. And, this is tested in different configurations. As I mentioned briefly, when we talk about the plugfest, we test conformance, right? When you have DUT against the test tool. And we also can run DUT to DUT interop tests, right? This is what we do mostly in the plugfest. And the conformance is something we run in the plugfest, but also vendors will run this as part of the getting their certification for conformance test. A couple of certification programs that are using time sync, right? Milan is one we mentioned earlier, right? This is the ProAV specific. Of course, time sync is one of the key TSN components. So this is a new program that is actually launching. It's not at open, but we are in the final steps to open it, soon. And when you do, so time sync is going to be one of the features that the vendors can certify on this program. And of course, TSN network switches with TSN capabilities. So these are, time sync is going to be used in those programs as well. Now, we want to share one use case, an example of one use case where maybe this time synchronization can be used, connecting to a remote cloud case. Like in most of the discussions so far, we're looking at ProAV or industrial, where this is more like a local network, but maybe there are use cases that connect to the cloud. And Ginio, you can explain a little bit more, given you come from the audio industry as well, audio video, and you can share more about this use case.
Yeah, this is I would say a use case that just start to gain attractions. It means we have first live events where we have in the venue a time-sensitive network. Here it's a Milan local audio network. That means everything is time aligned here, and we need there already a precision of plus minus 1 microseconds. So for example, when we have some loudspeakers that forms a wavefront, This is actually a tolerance of ±1 audio sample, and if this is getting a bigger tolerance, the wavefront is breaking. And so this needs to be avoided. But now it goes even a bit further, that now there is more and more the demand of at concerts to have a kind of augmented audio experience. That means giving additional content to the audience, not only the direct audio pass that is coming from the stage and the PA system. It's also starting with the wish to say, okay, we want to have an audio upstream, having some artificial intelligence processing in the cloud. And that could be also distributed cloud systems. But at the end, when we transport the audio, also for some immersive or surround application, it means everything needs to be sample synchronous and therefore very tight aligned. And then at the end, coming back from the cloud through a 5G network, transported to different mobile clients, meaning at the end, it's the phones of the concerts audience that is there, where, for example, they also can mix together with the additional content in real time and time aligned then again with the latency and the stuff to the audio that is coming from the PA system, and more or less form their own mix of the band, for example, to simplify this a bit, together with other audio video context. And this could be very interesting today. It's at the end, it's still a bit blocked on the audience itself. So there is, at least to my knowledge, not really a timing standard that can go from the local Ethernet up to the server in the cloud with the needed precision. I know that there exists a wide rapid network, etc., but at the moment, from my understanding, and I might be wrong, this is more on an academic level yet of the CERN, but could be eventually more. I know that 1588 has done some updates, but I thought it might be interesting to show a bit so that things are getting connected together, and therefore it would be interesting to also to know if this is sought or not.
Good. So yeah, any comments or any feedback on this? As we mentioned earlier, right? The synchronization, feature and programs in Avenue, they started from more like local area network use case, like Pro AV within the venue, right? And also industrial within a factory case, but automotive. But now we are hearing more and more about this new experience. So that would actually need to extend beyond that. And maybe that goes into the scope of the work done in this group as well, right? And it all be good to get the feedback also here, right? Is that something this group is looking at, or do you see any opportunity here, right, to also collaborate,
So Dave, I have a question.
Yeah.
Did you look at the case where the actuators and sensors in a factory floor and maybe other devices are connected to a virtual programmable logic controller in the cloud, which is connected to the factory using 5G network? How we do time synchronization in this scenario?
We did not. I have a slide I can use to show about what we look about 5G. I actually can talk a little bit about that, but I would say most of the use cases so far we are getting from the industrial space, for example, are assuming this network is going to be local or edge based or not necessarily the public cloud, right? I think so far, they are looking at like a private 5G network, That's been most of the use case so far, right? So in that case, you know, we did look into, and we actually have already a test spec to be able to, you know, synchronize a 5G device, right, with any TSN. I'm coming from a TSN network, right, across a 5G, you know, device. So that's the scope of the 5G synchronization and other, you know, QBV work as well, right? So that is something we've looked at, but not the cloud aspect of it, you know.
But the scenario that I'm talking about is the programmable logic controller does not exist in the factory. It's virtualized,
Right.
virtualized in the cloud, which is connected using 5G, private or public 5G, to
Yep.
the actual factory. How we do synchronization here?
Yeah. So I guess if, let's say, you know, let me explain the scope when we do synchronization across 5G, right? Let's say you have here the core 5G network, right? The UPF, right? And there is a network TSN translator, the dotted box here on the right side. And then there is a UEs, right, on the wireless side with this TSN translator as well, right? So 5G release 16 has specified how you do synchronization, you know, receiving a clock right from outside of the 5G network and synchronizing it all the way from the UPF, right, to the end device, right? So I guess, you know, if your case, right, let's say your virtual PLC, and by the way, we did look at virtual PLC in the private network, but I think your case is, okay, your virtual PLC is running on the cloud, right? And it could be like, okay, this test station here, I suppose this is your cloud device. As long as you can guarantee, you know, the synchronization from that point into the network gateway, like the NWTT, right? We can guarantee we deliver it to the end station on the wireless side, you know, within, you know, the accuracy, you know, specified in the spec, right? Things around 1 microsecond, but we do better than that. You know, but let's say that's a question I have, more like, if you run into the cloud, can you guarantee the synchronization from that cloud host to the translator of the network? That is not defined by the, you know, if you use GPTP there, you know, but maybe there is other protocols there, right? So that is the part that the 5G TSN specs do the translation, assuming .1AS is running on this test station and over the network, you know, that's the current scope.
Yeah, I spent some time in this world. It's been a while now. It first started about 7 years ago, then up to about 4 years ago. So my information's a little bit getting out of date now. But I will say that you have to consider, when in this case, for the Hashem's question, is that you don't forget that at this level, this is the best effort over the wireless part, right? So you have to, you probably don't want to run a PLC in the cloud on the best effort service. Although you can synchronize it, you can't guarantee the packets will arrive. So, but on the other hand, if you don't use the best effort service and use a guaranteed QoS service like ultra reliable low latency communication URLLC service, then you can also guarantee the transit of each packet. And so if you were going to run in your use case a cloud PLC, then I would definitely do it over URLLC on the wireless side. But as this diagram is drawn here, it is correct for the synchronization. So
yeah, good point. And actually, I'll just add the way the TSN is specified over 5G is actually a little bit different from Ethernet or even Wi-Fi. Is 5G is kind of a black box, because 5G is not like a 802 based technology, right? Not based on IEEE 802 standard. So what they decided to do in 3GPP was, okay, we'll have a mechanism to translate the time and ensure it's passed across the 5G, right, system for .1AS. And then for the latency, actually, and things like QBV, that's the spec that guarantees latency through scheduling in Ethernet, right? It's a black box, basically. 5G is going to take care of that. And the assumption is that they're going to use URLLC, like you said, right? So, and you get the requirements in this network TT, control function. And then you try to guarantee, 5G try to guarantee, but there is no spec to say how you do it. The assumption is that the vendors will do it based on URLLC or their scheduling, implementations and so on. And that's one thing that in Avenue we are trying to test. We actually will test both time sync. We already started this, by the way. The October Plug Fest, we actually had a 5G test for the first time. We tested time sync across a 5G system. And then the next test is ensure how you test and ensure that the latency is bound across the 5G system, right? When you get the packet on the OPF, you deliver it with determinism, meeting a worst case latency on the other side. So those are tests that we are running in Avenue for 5G. And we do that also for Wi-Fi, actually.
Yeah. In our time, we spent, I did a lot of simulation and planning for different scenarios, and it's the determinism that is the problem with this applications, right? Time-sensitive applications, even synchronized between, I won't say Wi-Fi, but Ethernet, TSN, and 5G is really difficult because of this QoS problem. So you have to really look at, when they look at deploying URLLC, there's also a network standard that goes on the infrastructure side that goes behind that, right? So not only do we have fixed the reliability over the air, but they have also improved the reliability over the wire, if you will. And so everything is going to respond within less than 1 millisecond and all this other yada, yada, yada.
Yeah, true. And there are a lot of tools, especially in a 5G system, and some of these tools are also include vendor-specific implementation, right? Of scheduling, for example, over the air on the G-Node B. That's a vendor, specific, but it has to guarantee the access to the channel. But I'll just say the time sync and the latency, so these can be decoupled, right? So I think there are already protocols, and we are actually measuring it. One thing is to time synchronize. The other is guarantee latency. You will use time to guarantee latency in some of the solutions if you use QBV as well. But you can. I think the results we are getting in time sync are very good across. Of course, it's not at the single, tens of nanosecond, but it's hundreds of nanosecond, hundreds of microsecond, no, nanosecond, I would say, less than a microsecond when it goes over wireless, and over 5G system, right? And it's not as good as Ethernet, but it's actually pretty good for many use cases.
Yeah, there's a whole universe of things you have to look after, and another problem is that you have to have kind of like deterministic OS scheduling and things like that at the far end and the client side too. Otherwise, it appears like failures and so on, or latency targets missed.
Yes, good point. So actually, this is the conclusion. This is the last slide we had. Just a few words again to recap, right? As I mentioned earlier with Guineo, Avenue is an industry group, basically open to companies, entities interested in driving this ecosystem for deterministic networking. We are driving it through test specifications and certification programs. And, there are already test specs testing for many of these core features. We went a little bit in details on .1AS, but they are already covering both wired and wireless, with being tested with a number of test tools that can be used for validation, and we we think some of these TSN capables, can be used across different markets, and members in Avnu are really trying to drive the efforts to define what are the priority features and what types of tests we need to do, right, and what the key use case for us, right, that we should look at, And yeah, we'll be happy to discuss further, if you have more questions. But.
And I think maybe also to conclude, the effort needed also to write test plans and to figure out how the testings are working and get it streamlined, it's not negligible. So, and this is something I personally have really appreciated and started to appreciate and to understand when joining the association, that really, so yeah, you can bring a lot of people from different fields together that have this knowledge, and you get much more out than if you try to do it in your own silo.
Yeah,
so, and this is a big benefit that should not be underestimated.
Yeah.
No, as OCP, this is a great. I love this. This is great. Been in this area for a while, and I really was only tangentially aware of it. You guys made this key points here, and I love it. A couple of things though is one thing I'm dealing with here is that complexity is growing. As we worry about scale out technologies, they're optimizing Ethernet underneath our feet. And so things are changing both in IEEE and MEF, and now we have other consortia like UEC, that's Ultra Ethernet Consortium, and others. And so underneath our feet, they're changing some of the performance characteristics of Ethernet. So this complexity for us is pretty high. And so we got to figure out some way to manage our way through this, right? Because testing could become very complex.
Yeah, and I'll just add to that, at the end of the day in Avnu, it's like the last point I made here, right? We are, really, it's not that Avnu is going to decide what to be done. It's really the members that have to get together to decide, what features to look at, right? What new features are coming, like you say, things are changing. When is something ready that we should look into testing that, right? Because some things may be not ready, but also what features in what markets, should we prioritize, right? So features that are used across many markets are definitely get high interest from the members. Also like said, right, in the end, the members come together here and need to decide, right, on that, right? And that's in the end you have to prioritize, right, and see what you can't do everything, but that's being part of Avnu, you can actually influence that, right, with other team members. We have silicon vendors, device vendors, and so on. We start with use cases. We do MRDs for certain features, and then from there we go to test specs. So there are processes we use to prioritize as well.
What kind of certifications, what do they look like? I mean, are they some sort of stamp the product gets, or?
Yeah. Maybe you'll comment on that, right?
Yes. So at the end, there are certification marks that can be applied. So I used the example of the Milan Pro AV. So here we have a certification mark that when the certification is granted, the vendor can put on his device, and it's visible to everyone.
Okay.
And that's a good way.
Yeah. So I was just gonna add, on the TSN component case, right? Something we are actually about to launch. That case, the device is gonna get a certificate that lists the key features that are tested, right, and certified for. So So, and we can list the products also on the website, but you will basically get a certificate, with indicating the features you passed, the certification on that program.
So as a designer, I could look at, say, I don't know, pick a name, Broadcom, and then their component has passed your certification. I could look for the certification, then I know I can build on these features.
Yeah.
Yeah,
Build
correct.
with these features.
Yeah. So
Yeah. You can
That's
trust, at least that has passed, like the basic TSN certificate component should be, following the specs for those features, right? That's why the certificate lists the features, because as we discussed, TSN is very big, and we don't test everything, but we test some of the core features, right? So like .1AS, for example, QBV, those are some of the priority features. QAV, QBU, so on. Okay. Any other questions? All right. So I think that's all we wanted to share. I mean, if there are more questions or interest to know more, please reach out. And Ahmed, you have my contact, right? We have to come back and have further discussions. As I mentioned, I didn't talk much about the wireless programs today. I wanted to give a high level overview, but we definitely can come back if there is interest to talk more about those, right? Both the Wi-Fi and the 5G. That's
That
something
reminds me, I do have one question. So do you have does Avnu have certified test labs, or do you certify test
Yes,
labs?
we do have
Mhm.
a number of test labs are listed here. There are 4 of them at this point that they are used. Yeah, so far.
Okay, thank you. Sorry. Is there some sort of high-level roadmap on your website or your specification?
I don't think it's in the website. That's something we can share. Let me see if I actually did not have it here, but of course, some of these are confidential to Avenue, but there are some high level we can share. I can actually put maybe
From
put some
many
back
scraps.
here.
Looks good. That was all scrapped, my brother. You're proud? Tastes good.
Aylan, would you please?
Do you like that?
Sorry. I'm not trying to get you to say anything. I'm just saying that we have a roadmap. Everything that we have has a roadmap. We're evolving. Like for example, we're looking down the road at quantum timing, right? Synchronization, things like that. So
Yeah, we do have roadmap for these programs. Basically, the component program, like I mentioned here, for now we're about to launch release 1. There are other features that will come. 5G, Wi-Fi, 5G. They are actually. We have a roadmap to launch them as well in release 1, work on release 2, and so on. There are, each program
on each
has
field,
a roadmap.
yes, yeah.
Exactly.
thank you. Okay.
Yeah.
All right, so just like a quick question, like how far are we with having hardware timestamping, let's say in Wi-Fi, so we can have precise time for Wi-Fi?
Yeah, so in Wi-Fi case, we actually already have run already a number of plugfests. So we already have this .1AS running across the Ethernet and Wi-Fi with that implementation over Wi-Fi as well using FTM. We have vendors already, participating in number of plugfests this year, right? So that is already there. The program is not open yet, but we have got already devices, in the plugfest testing it.
So is there anything commercial available now in terms of like radios we can get with the FTM?
Yeah, well, I can speak for Intel here. I'm from Intel as well, so we do have AX210 chipsets, right? That support that, you know, in FDM already, you know, and they are available. Driver is available. Of course, not the whole implementation of .1AS is yet available, but you know, we can discuss offline if you are interested. I can point you to
Yeah,
the
yeah,
right
I am very
information.
interested. We have also Nobu. Do you want to add something to it?
Yeah, so yeah, I have a question about that. And can we get the, well, you mentioned the FDM, and can we get the chip state information as well on your chipset?
Yeah, so I can discuss more about that, but yeah, it's the AX210 is the chipset, right? That has the FDM support, you know, from Intel, you know.
Okay.
Yeah.
Yeah, I can.
Yeah.
Offline.
Yeah, please feel free to reach out to me directly. We can discuss.
We will
offline.
reach out right away. This is very important for us.
Okay.
All right. Great. Any more questions before we close the call?
All right. Thank you, everyone.
Okay. No questions. We'll see you guys in 2 weeks from a call by Stefan Meyer, which is about 5G PNT using TV transmitters. So wish you guys a great day and rest of the week. And I think for the Americans, like Thanksgiving and happy holidays.
Thank you all.
Thank
Thanks,
you. Bye-bye.
Yeah.
Thank you.